I'd like to welcome you all this morning. I'd like to thank you for investing your time to attend this webinar. This is an inaugural webinar from my perspective. This is the first time that we've delivered this particular webinar, which is the acoustic imaging for manufacturing, capturing cost savings through sound, which is a bit of a mouthful, but the title says exactly what this is going to be about. Just to introduce myself, my name is Jason Cargill. I'm the technical sales specialist for Teledyne FLIR, covering the UK and Ireland region. And I have other colleagues dotted throughout Europe who are also on the technical sales specialist team. So my role today is to deliver this content in regards to enlightening you about this technology and what we believe that it can offer for you in your particular places of work and the environments that you work in. So run through a quick agenda this morning. So we're going to look at the cost of hidden leaks, why we're going to use acoustic imaging for leak detection and what the benefits of it are. We're going to couple a couple of application stories of real life results with this equipment. We're going to look at achieving rapid ROI. Return on investment is a big part of what we look at within Teledyne FLIR with our product range. Obviously, investing in any of our equipment is a big step for customers to take. And what we like to try and do is offer the opportunities to show what that return on the investment can be. And we've certainly had cases with acoustic imaging in particular, which have proved to be extremely fast return on investment cases. We're going to do a little slide about sustainability, which in the current climate is obviously on everybody's lips. We're going to look at introducing the solutions that we have specifically for air leak detection. We're going to touch a little bit on software and reporting, and then we'll have the Q&A session at the end. So what I'm going to do now is I'm going to get rid of my face from this particular presentation so that you can concentrate on what's on the screen. You'll still be able to hear my voice from the ether, and we shall proceed. Okay, so we talk about the benefits of sound, but more importantly, it's the benefit of actually being able to see sound. And that's a really powerful statement to be able to make with this type of equipment, because we obviously are all aware that we can listen to sound, but to be able to actually see sound and visualize where it actually is located is a very powerful tool. And what kind of benefits can that actually bring when we look at that ability to visualize those sound patterns? Well, we can find hidden problems. And, I can give you a real life case where I did a demonstration with an SI-124 in an automotive manufacturing plant. I managed to find a leak in a nitrogen system, which was not at a termination or a connection. It was actually in the middle of a pipe. The pipe was pressed hard against the side of a machine. Every time that machine started up, it started to rub the surface of the pipe, and gradually over time it created a small hole. Now, with the ability to use an acoustic imaging camera with its wide field of view, I managed to scan the area quickly and locate this particular leak. And upon further inspection, it was literally caused by this friction over time. There was a lot of background noise in this environment. There's no way that you would have been able to find that leak because you couldn't hear it for the start. You would never have seen that there was a problem with the pipe because the hole was on the side which was pressed against the machine. So it may be a rare case, but for me it was an example of a real life scenario where I found what was an expensive leak because this was nitrogen as a product. And as we'll go into more detail in forthcoming slides, we'll tell you more about the sort of the interpretation of the camera in regards to those sound patterns that it actually sees. So yes, we can find hidden problems easily and quickly, more importantly. We can then save costs. We can also improve efficiency, whether that's improve efficiencies within the manufacturing operation or the production operation, or efficiencies within the way that, for example, a maintenance team may operate, but efficiencies can be gained on a number of different levels. And then we can also ensure quality and safety, which in anybody's working environment, these are two, quality and safety are two words which really people are focused on all the time. So in one slide, these are only some of the benefits of being able to see sound with an acoustic imaging camera. So I've mentioned hidden leaks, and hidden leaks equal avoidable issues, because these kind of problems can be mitigated against with the ability to locate them quickly, because undetected leaks can lead to serious consequences within a manufacturing operation. And these can include increased energy costs, reduced operational efficiency, unplanned downtime. And unplanned downtime in particular is a difficult problem for maintenance operations to deal with by its sheer nature. If a manufacturing facility is in full flow and there's a problem with a piece of equipment that causes that operation to stop even for a short time, it can be a severe issue getting that problem remedied, which can then result in increased maintenance costs. Reduce service life of assets, because ultimately, if, for example, compressor systems are working far harder than they need to achieve the output that's required due to air leaks, then that's going to reduce the overall surface of that, the service life of that equipment. We can have the loss of costly specialty gases. I've already mentioned an example with which involved nitrogen. And it's kind of important to sort of highlight at this point that although the SI-124 acoustic imaging camera doesn't identify different types of gases, the camera is listening for turbulent air sounds. So when you have a leak which creates turbulence in the air, that sound pattern is what the camera listens for. And due to the fact that there's 124 microphones built into this device, and these microphones, even in themselves, they're called MEMS microphones, which stands for micro electrical mechanical systems, but basically they generate a very low signal to noise ratio. So that therefore enhances their ability to be able to pick up those problems and those turbulent air patterns. So although nitrogen is a different molecular structure to compressed air, it still creates turbulent air. And that's why even with non-compressed air type leaks, the camera will see a turbulent, will hear a turbulent air pattern, and it will then be able to visualize that on the screen. I'll go into more detail about the quantification aspects of the device, but ultimately the SI-124 will hear turbulent air and the sound that creates. And then we can also have potential operator safety risks, because some production environments are extremely busy areas. I mean, this one snapshot alone that gives us an example of, you know, a large production facility, and it also indicates the kind of benefit that can be gained from having a wide field of view within the camera that you're using. And you know, with the SI-124, you know, we have a 62-degree field of view, which is very wide, which allows you to scan those areas very, very quickly. But also a problem you can have with issues with air leaks is also impaired product quality in your production facility. So there's kind of a domino effect which can be felt around this type of environment when you start to have problems with air leaks. And in some cases, it also means that you're non-compliant when it comes to regulations, which creates another problem in itself. So, you know, what are the real costs of hidden leaks? Well, generally, compressed air systems can lose 25 to 30% of air to leaks, and that straight away results in those higher energy costs. It also means that you may need to purchase extra compressor equipment to meet the requirements of the tooling that's being used because of that lost air. And then replacement equipment costs can increase as well. So therefore, over the lifetime of some of these compressors, and some of these compressors are working major shifts of operation on a daily basis, 365 days a year, any potential of reducing the life of that type of equipment, which can be very expensive, needs to be mitigated against as much as possible. And as we've mentioned earlier on, the extra maintenance costs involved as well, with additional equipment being installed or repaired, is also a factor that has to be taken into account. But when we look at the overall picture, if you look at this pie chart at the top on the right-hand side, just as an example, even when you combine the costs of equipment and maintenance, the electricity can be well over 3 times the cost of that equipment and maintenance. So therefore, any opportunity to save electricity needs to be looked at very, very seriously. And obviously in this day and age, in the world that we all live in now, energy costs, they've gone through the roof, both domestically, commercially, and from an industrial perspective. And this type of equipment can certainly help to reduce some of those costs. And then when we look at this pie chart at the bottom, just in regards to, where does the air go, from a demand perspective, we can estimate using this courtesy of the compressed air challenge information, approximately 50% of the air which is produced in systems is used for production. We've already mentioned that leaks can account for 25 to 30%, and then inappropriate uses and artificial demands can also add up, to a 20+% figure. So the estimation is that we're using far less of the air for actual production requirements, which is not really where any production facility wants to be. So why do we want to use acoustic imaging? Why do we recommend that we use acoustic imaging? We can see from this chart here, which is kind of a dipper chart, there's a certain points on this scale where we can use different types of technologies. And essentially, this is shown as the degrading of a piece of equipment over time. And obviously, Teledyne FLIR, as everybody knows, we are specialists in thermography. And thermography has an extremely solid place within this type of tooling to use for detecting these problems. But the inaudible sound that acoustic images can detect, that really puts you right at the start of this curve, and the best place to be to identify where there's a problem. So as an asset starts to deteriorate, it starts to emit a sound. And again, you can eventually pick those up with the likes of vibration technology, but ultimately those sounds are inaudible to begin with. And it's extremely powerful to be able to pick those problems up early on. So therefore, we can help prevent potential failures. We can help save money and time. And ultimately, from a predictive maintenance perspective, which is the panacea for most maintenance departments, it gives us a really strong tool in the arsenal to be able to do that. But importantly, it's that ability to visualize those sounds in real time. So you can locate them in real time, quickly, efficiently, and accurately. And even more importantly, you can record that data. So we have an example. This is just a very simple graphic of, well, where can you find air leaks in a facility? And this is just a simple example, but there are a number of places where you will suffer potentially with air leaks. And again, we can run through some of the obvious ones like couplings. So anywhere where there's a joint or a coupling, or there's a junction, there's always the potential for problems in those kind of environments. But then there are other places maybe which you wouldn't be quite as familiar with. For example, condensate traps. We can look at thread sealants, and also some types of valving. But ultimately, this is a snapshot of areas where you may have problems. I mean, I've done enough demonstrations now with the SO124 to know that every production facility has air leak problems. It's a question of how serious they are. And ultimately, it would be very difficult for a production facility to fix every air leak. But it's those serious ones that are costing the most serious money. They're the ones you want to be able to find quickly. And the SO124 certainly allows you to do that. So we have a little bit of an application story here in regards to enhancing quality and safety. Leaks can disrupt functionality within manufacturing equipment, which, as we've spoken about earlier, can lead to impaired product quality. That means you can have problems with the materials that you're producing. You can have excessive scrap being generated, or you can have contamination within the production facility, depending on what type of media that you're working with. And those undetected leaks can also lead to risks to operator safety, which could be the release of harmful contaminants, noise pollution, and potentially hazardous accidents. But with that swift detection and the ability to then repair quickly those air, gas, or vacuum leaks, then the acoustic imaging camera can certainly allow facilities to be more uniform in their production quality and can help reduce those safety concerns. So then we look at, well, okay, what are the potential effects on savings in regards to employing acoustic imaging within your facility? Well, we've already highlighted the fact that most production facilities, if not all, will have some kind of air leak, and some equipment is prone to air leaks as well. And we've given a figure of 25 to 30% as an estimate for a leakage rate, but in some cases it's been reported to be as high as 80%, which is extremely high and on the extreme end of the scale. But ultimately, if you don't know how much air you're losing, your facility could be losing a lot more than 25 or 30%. And those hidden air and gas leaks do lead to those additional costs with the unplanned downtime and the potential safety hazards which can be created. They can also cause those substantial financial losses on the specialty gases. And I think that's the important thing to highlight again, is the fact that the SA124 acoustic imaging camera will listen for turbulent sound patterns created in the air through air leaks of any description. It's that movement of air which the camera will listen for and be able to visualize. And it's that early stage ability to pick up on these things right at the start, a bit like when we looked at the chart earlier on, to be at the start of the chart before things start to deteriorate to the point where you do have to employ other types of technology, or it eventually catastrophically fails unexpectedly. Then it's a really important part to try and also hone a maintenance budget and stay within that budget. Because the one thing I've picked up on in the many years I've been in the industry is maintenance departments generally have to do more. They have to do more with less people and usually with less budget. That may be a generalization, but I've spoken to enough maintenance managers over the last 20 years to be able to see that that's the way that the trend has gone. So maintenance operations in particular, or energy assessors, are certainly interested in any type of technology which can help them improve their operation. So benefits of using an acoustic camera: save time, energy, and costs. I know I keep repeating the same things, but these are the key kind of cornerstones that we're looking at with investing in this type of equipment. You're looking at increasing your operational efficiency by preventing that unplanned downtime. And again, this large area scanning, and again, me and the rest of the technical specialist team have visited sites, and we are well aware of the ability to scan large areas very, very quickly and pinpoint those problems accurately. Minimal training is really required with this device, and this is kind of where we're moving away from the traditional acoustic technology where you'd have the parabolic dish on a gun and you'll have a set of earphones on. And, you know, acoustic imaging is not trying to replace that. This is an addition to the acoustic testing technology, but it's a lot faster in regards to identifying leaks. We can also carry out inspections without halting operations, which again, you know, just like thermography can, you know, the ability to scan areas and pick up on issues while operations are in full swing is an important factor. And I'll say again, it's this real-time results, and it's real-time on the screen as well, which you'll see soon in regards to the amount of data this device can give. Sorry, itchy trigger finger there. So rapid ROI in a large facility. So this is a case that we've had within our business. Industrial operations are very noisy by the nature of them generally, and therefore it is challenging to be able to accurately find those particular leaks. But at a recent inspection, the Si-124LD, which is the latest addition within the leak detection range of camera, was I able to identify 155 leaks in just 6 hours within a 6,500 square meter manufacturing site, with their ROI, return on investment, estimated within 2 rounds to be 4 to 6 months. Now that's one example. We've had examples which are faster than that. I had a recent case within the last 3 weeks where I visited a manufacturing facility, actually to demonstrate a different product, but I was able to show them the Si-124. There was actually a leak in the office that we were in, which was the reason why I was able to show them. I then gave one of the maintenance operators the camera that he'd never seen before. I was able to show him how to operate it very quickly. He then went out onto the production line and he came back in within about 15 minutes with approximately about £9,000 worth of leaks that he'd identified. Now, again, could be at one end of the extreme range, but certainly I've been on enough visits personally to know that this device really does have that power to be able to pick up really bad leaks quickly, and therefore put you in a position to be able to resolve them. Gases, again, we talked about, but CO2. CO2 is used a lot within the food and beverage industry, for example, amongst other types of manufacturing. And then we have argon and nitrogen and many others, which are costly, far more costly than compressed air. And then during a recent inspection, not mine by the way, but within the business, it was able to locate 5 specialty gas leaks within 10 minutes, resulting in annual savings of approximately €12,000 and an estimated ROI within just 2 months. So these are real life cases based on experience that we've had. And again, I can, from my personal perspective, I can quantify the fact that the device can operate in these conditions and offer these kind of results. Now, from our perspective, to help you to be able to work out your ROI, we do have an ROI calculator. This QR code will actually work now if you wanted to have a look at it now live. But ultimately, this is what the tool allows you to do. There's some parameters that you have to enter, but then ultimately you can end up with a breakdown of results at the end. So certainly after this presentation, this webinar is completed, by all means, take a look at the ROI calculator that we have. It's a very useful tool and could certainly help you. Okay, a little bit on sustainability. It's something that everyone's trying to strive to be more sustainable as businesses, and ultimately something as simple as identifying, repairing an air leak promptly. The knock-on effect of that is to help minimize energy consumption, excuse me, and carbon emissions, and can contribute to a greener manufacturing process, aligning with sustainability goals. This is probably not the time to have a coughing fit, excuse me. Improving energy efficiency. Timely leak detection ensures that energy is not wasted when compensating for air leaks, with that extra work compressors have to do, because potentially 25–30+% of that air is going out into the ether. So therefore, it also helps reduce the environmental impact on your operations as well. So when we look at Si-124LD and LD Plus as a benchmark, the LD and the LD Plus are the 2 models that we have within our range of solutions for leak detection specifically. The Si-124 family as a whole incorporates models which can also detect partial discharge, which will be a separate discussion. But LD stands for leak detection. So if you're talking about an Si-124LD or LD Plus, then you're talking about a device specifically optimized for compressed air leak detection. So best performing acoustic imaging camera range, saving time, costs, saving energy. Safe and easy to use, very easy to use. Using only one hand, you know, it's just like holding a thermal imaging camera. It is one-handed operation. You can actually operate and capture images with your thumb on the screen as well. So it is, you know, you can hold and capture images with one hand to gather that valuable data. And it provides real-time information, real-time data on leak size and also the knock-on cost for that leak. And then, you know, this is an AI-driven device which has functionalities which allow the user to have a really good experience and a seamless experience, because the display is very intuitive as well to use. So, rear view of an SI-124 camera: find fast, fix fast. I mean, literally, that is what it is, what it says it is. You can find the leak fast, and it allows you then to fix it fast. So what we see here is we have a marker, a little heat map marker, which is located on the screen. So those 124 microphones are looking out at that field of view. It's detected. It's actually set up in this case to detect one. Let's get my laser pointer working. So on the screen here, it's set up to detect one source of sound. Now this can be changed to multiple sources, but ultimately the worst leak in the field of view will always have a crosshair on it. So it's handy to know that you can detect multiple leaks at one time if you change the setting here on the screen. It's a simple press of this icon. But the worst leak within that group will always have a crosshair. At the moment, this is set up to be as a single leak device. So each sound source is also indicated with a color. So what the device allows you to do, if you walk into a large area and it picks up a leak quite a way away, now the specification within this device operates up to 130 meters. If the color of that leak on the screen is not green and it's orange or it's red, you know straight away, just from a color perspective, that that's a bad leak, especially if it's red. So it's a strength marker. So it's indicating the strength of that leak, even from a distance, even before you have an accurate assessment of the leak estimate in liters per minute, or whether it's the cost. Actually, visually, you can sweep an area really quickly, and even the color of the marker will denote whether that's a really serious leak. And I've been on visits myself where I've picked up on leaks which are not just green. They are orange or even red in some cases. So this is a really good visual tool to be able to pick up that information. And I've already said it, but it's that wide field of view. So you combine the wide field of view with the colored marker, even before we start looking at numbers and data. It's a really good tool for identifying those leaks. And as I've already said, the multi-source mode will allow you to identify the worst leak within a group as well. So we talk about real-time data, and again, this is what the information which you can get from an SI-124 on the screen. So the leak rate, or the leak size, which can be in liters per minute or cubic feet per minute. It's up to you to set that parameter. It's based on the sound intensity of the leak, the distance, and the specific power of the compressed air system. And all this data can be entered into the device. So in this area here, we can see the decibel level. And what you'll notice on this area when you're actually using this camera, as you move towards the source of the sound that you've identified, you will see that decibel level increase. And ultimately, although this camera can operate up to 130 meters, for the best results, you need to get as close as you can to the source of the sound as safely as possible. The advantage of this device being non-contact, it means that you can be further away, but we also have the ability to utilize a zoom feature here. So there's a 2x zoom feature, digital zoom feature on the camera, which you can utilize to get that bit closer without physically having to move closer if it's not safe to do so. But the best results you get with sound patterns is to get as close as possible to the sound. So the ability to identify a sound, an air leak, up to 130 meters is great. But ultimately, you always try to move as close as you can to get the best result that you can, to get the most accurate data. And what we can see from this particular part here is decibel level, and then there's your leak estimate there. So 23 litres per minute in this case. You will have installed or entered a kilowatt hour figure into the device before your inspection, and based on that kilowatt hour figure, the camera will then tell you what the overall cost of the year over the year will be. So what we can see in this case is over a year, that particular leak was costing approximately €740. So that's that real-time data you get off the camera straight away. So regardless of where you are in the operation, you turn the camera on, you get your distance, which this distance is important because sound drops off quite quickly over distance. So unlike thermal imaging cameras, which can work over longer distances depending on the size of the target, the sound frequency drops off, the sound pattern will drop off very, very quickly over distance. So we talk about solutions. So we've got two solutions for leak detection. We've got the SA124LD, 124 relating to 124 microphones. And we have the LD Plus. So the frequency bandwidth that these cameras operate with both within is the same. So 2 kilohertz to 65 kilohertz. And the majority of industrial noises we deem to be around the sort of the 20 to 30 kilohertz range. And those lower frequency sounds do actually travel further as well, which is something to take into account. I've already mentioned that it's up to 130 meters in regards to operation. But importantly, in this case, the difference within these two models is the LD Plus is a more sensitive camera. So based on minimum detection levels at 1.2 bar and from less than a meter away. With the LD model, you've got 0.016 liters per minute minimum detection. LD Plus, you've got 0.004 liters per minute. So the LD Plus is a more sensitive camera. The LD Plus also brings to the functionality of the camera that you have an automatic frequency filter. And ultimately, that's what the ability to filter out that background noise and really highlight what the problem noise is. The filter systems within both cameras do that very, very well. With the LD, you can select those frequency filters manually. With the LD Plus, it will do it automatically. It will listen to the ambient sound, and it will operate within the filter it deems to be best at the time in that circumstance. And then with the distance that we talked about on the screen, you can manually select distance on the LD version, but on the LD Plus version, it has an automatic facility which operates up to 5 meters. So again, when you locate a problem from further away, you can then get closer to that problem. And with the LD Plus, once you get within 5 meters, it will automatically calculate the distance on the device. So that's a very high level snapshot of both models. But they're the two models which are available within the range, specifically for leak detection. And this is when we look on the screen, this is a close-up of the screen that we can see here, plus and minus. In this case, it's from an SI124 LD Plus because there's an auto feature there because it's about 4 meters away. But again, it's that auto filter, auto distance, which are the key differences when coupled with the other additional sensitivity. ISO 5001 reporting compatibility. I think for anybody's I think for anyone's operation in regards to being able to improve your energy management systems using ISO 5001. I mean, ultimately, it's the ability to be able to record the data, which is really important. And within the SA124, we have the ability to set up a cloud account as an online viewer, or certainly for existing users of our thermal imaging technology. The SI124 is compatible with Thermal Studio Pro. So anyone who's currently using thermal cameras from FLIR, Teledyne FLIR, you can invest in a small investment in a software plugin, which allows you then to utilize Thermal Studio Pro. You can even combine reports if you wish for acoustic and thermal. But this is another advantage from our perspective, is the ability to use the software ecosystem that we have And again, this is just a very simple report shown on the screen, but gives you the data that you need. I mean, ultimately, what you need an acoustic imaging camera for, you want to be able to find leaks quickly, you want to fix them quickly, be able to cost them. And this kind of information can be entered in a report, which from a recording perspective and to align with ISO 50001 can be important moving forward for yourselves. We have a QR code here for the website, and we have some additional support. In fact, we have a lot of content within the Teledyne FLIR website, which includes data sheets and product manuals and a lot of information which you can utilize. I think I'd also like just to say to juncture as well from the perspective of technical sales specialists within our different regions. Certainly, I'm the technical sales specialist for UK and Ireland. You know, I can give you data in this type of presentation, you know, based on facts, and I can talk about, you know, experiences that I've had personally utilizing this and using this equipment. But ultimately, you know, the real power of seeing what this equipment can do is to see it in your environments. So certainly from the perspective of the technical sales specialist team, you know, we're more than happy to work with our colleagues within the different regions to arrange site visits, to do live demonstrations, because ultimately, you know, we want as many people as we can to really see this technology, and even more importantly, put the technology into people's hands. You know, when we talk about minimal training required, that is not an underestimation to say that minimal training is required. I'll give you another quick story because I'm just watching the clock. This Q&A could be very short, unfortunately. But did a visit to a BMW site. I did a presentation in an office. We weren't going to go on the production line. I did manage to get 5 minutes on a production line. I gave the camera to an apprentice who'd been at the meeting. The apprentice found a couple of leaks within a few minutes with very, very minimal instruction. So, you know, this really is equipment which is easy to use, but is extremely powerful, certainly from a maintenance perspective. So I think we're down to the Q&A session now. I'm just going to turn my camera back on. I hope that's been informative for you. Again, this is a high-level webinar in regards to detail. I think ultimately, you know, there are more of these webinars which will be delivered within the different regions. Please keep your eyes open on LinkedIn and other platforms for any heads up on this type of information. You know, we certainly want as many people to see it as possible. I think my camera should be back on now. So, all right. So I'm going to have to look over this way because I've got multiple screens at the moment. Okay. Yeah, we will be sharing the slides afterwards. Okay, can we go deeper into visualizing vacuum leaks, please? I think what I would say at this point, there will be other webinars which go into more technical detail. I think the idea of this webinar, I know that the idea of this webinar today was to give sort of a broad-based brush over where acoustic imaging can fit into manufacturing. I think, you know, there's a lot more detail to talk about, and, you know, we've got other capabilities within the SO124 camera range. I mentioned partial discharge, which is another webinar in itself. But this is a very, very powerful piece of equipment. And certainly, yet the devil is in the detail. And from my perspective, we can certainly look at offering more follow-up information from a technical perspective. I think as well, the questions made about quantification as well. I think what we have to understand is that the SI124 is optimized for compressed air. So any cost calculations on the device relate to compressed air only. Again, that doesn't mean that you can't find leaks with those specialty gases. And what you can make is a judgment call on what the cost could be. For example, if nitrogen is 5 times more expensive than compressed air, you can give an estimate of what it could be costing. So the camera will only quantify the cost calculation related to compressed air. but you can make a judgment call yourself in regards to the additional cost of any specialty gases. As far as hazardous areas go, no, this unfortunately is not any X-rated product or intrinsically safe product. Not at the moment. But obviously you do have the benefit of distance, and depending on the sound frequency, you may be able to pick up air leaks well out of a particular zoned area, but it's not certified for that type of use. Looking for a tool to detect noise leakage from computer rooms to adjacent office space. I think ultimately this technology can operate down to very low levels of air pressure, but to be able to use the functionality and the quantification tools, we're looking at kind of 1.2 bar minimum pressure. That doesn't mean it can't detect lower pressures, but it can't quantify them. But what it does really rely on is kind of a uniform sound pattern. If you have a very diffused sound pattern, that may be more difficult to try and pick up sound with air leaks with those types of sound patterns. I think ultimately, from my perspective, I'm always very keen to try any application for this type of technology. I've had interest in looking at air pressure within buildings and air loss within buildings, which it's not specifically designed for, but there's 124 microphones listening for sound patterns, regardless of how they're created. So we're always willing to look at trying new options in regards to new applications. So sometimes the only way to find out if it does truly work is to be able to try it live on site. So please bear in mind, these visits that we can arrange, these are non-obligation visits. You don't have to purchase anything. Obviously, we'd like you to, but ultimately, you don't need to make an investment initially. We just want to be able to prove the concept within your environment. So as a technical sales specialist, I've done many visits now within the UK and Ireland. My colleagues do the same in their regions. For the sake of maybe an hour on site, we can really prove that the technology, in most cases, can do what we say it can do. Yes, you can find vacuum leaks. Again, it's that movement of air. That's what the camera is listening for. And when it comes to acoustic imaging, more speakers is better. It's like having a higher resolution thermal camera. It's a very simple statement to make, but the fact is those extra speakers do bring some extra capabilities within detection of sound patterns. Can you use it outside the building? Yes, you can use it outside the building. Again, a real life scenario. I did a visit over in Ireland last week. We visited a premises where we went outside. We managed to find a leak within about 2 minutes. Again, a place that you would never have found. It was under a cylinder. It was a reflection off a floor, but it was outside. And so you can use them outside. It's all dependent on the sound frequency and the strength of the leak, but you'll definitely find leaks that you don't know you have with this equipment, whether it's on a demonstration visit by me or one of my colleagues, or if you invest in the equipment yourself, you will find leaks. I've got any success story with SF gas leaks on electrical equipment. That's probably not a subject I want to go into now, because to be quite honest, I'm not aware of anything specifically. But again, when we talk about specialty gases, turbulent air movement, and the camera listening for sound patterns, anything that causes turbulent air, particularly being released from a gas leak, it will be identified on the camera, as long as it's not too low. But ultimately, that's warranty period is 2 years. And you just need to make sure that you register your device when you purchase. So it's a year and then plus a year with registration. How can we adapt this leak test to commissioning, qualification, and validation? So how can we adapt this leak test to commissioning, qualification, and validation of pharmaceutical industry's equipment? Wow, that was a bit of a mouthful. I'll take that one offline. I mean, I'll be able to look at these questions after the fact, and we'll come back with maybe some more validated answers. I'm sorry I can't be more specific in this particular environment. Sales department details. I mean, ultimately, I mean, I'll confirm with my colleague, but I'm pretty sure that this information will be shared. We have your email addresses in regards to registering, so I'm sure we'll be able to facilitate the providing you with the information that you need for your particular regions. I'm not sure what the score, the time here. We're on 10:46. I mean, I'm quite happy to keep talking, but I know that we've only allocated 45 minutes. Okay, no more questions. Well, it looks like we did that within a day. We came in on budget. So again, I'd like to thank everybody for your time today. I hope it's been informative for you. As again, this is just one of many webinars that we'll be running as a team. And again, please don't underestimate the effect of having a live site demo. No obligation to purchase, but you will get to see this camera working in your environment. And from my perspective as a TSS, that's the place I'd like to be, to show this technology and spread the word about acoustic imaging with the SI124. So thanks very much for your time and have a good day. I'll see you again at the next webinar. Thank you.